So this is the 2010 free response area volume question that you guys are supposed to be working on between the end of class yesterday and today. So we'll just real quickly go through it all. So for part A, we're just looking for the area of this region. So the area of the region ought to be the upper function, which is y equals 6, minus the lower function, which is 2 minus root x. So part A, we'll do, let's see, it's an integral from, where was it, from 0 to 9, I believe, of 6 minus the quantity. I don't need a quantity there, it's just 2 root x was the function, right? 6 minus 2 root x dx. And so if we integrate that, we end up with 6x, and then the integral of the root x is 2/3 x to the 3/2, so that'd be minus 4/3 x to the 3/2. And we'll evaluate that from 0 to 9, giving us 54 minus 36 minus 0, which is 18. And so 1 point for the right setup, 1 point for the right integral, 1 point for 18. Everybody good with part A? I'll assume that's a yes. Okay. For part B, we want to just write the expression that gives the volume if we revolve that region around the line y equals 7. So we're going to go around y equals 7. And so if we're revolving around that line, we're going to get washer cross sections because our region is not fully pushed up against what we're revolving around. And our outer radius ought to be the distance from 7 to 2 root x. So this right here is 2 root x. The whole thing is 7. So that outer radius ought to be 7 minus 2 root x. And our inner radius ought to just be the 7 minus the 6, or just 1. So we should have an integral, or pi times an integral, from 0 to 9 of 7 minus 2 root x squared minus the 7 minus 6 squared dx. And just writing that as 1 squared or 1 is fine. 2 points for the correct thing inside of here, and 1 point for the right interval and the pi. Everybody good there? Any questions on part B?
Nope.
All right, and part C now says that this region is now the base of a solid, and cross sections perpendicular to the y-axis are rectangles with heights 3 times the length of the base in the region. So there's my base, there's my height of 3. So base and 3 times that base. And we need to do this all in terms of y because the cross sections are perpendicular to the y-axis. So we'll start with figuring out what the base is. The base is just whatever x distance we've gone over. True? So since our base is just x, we should be able to solve y equals 2 root x for x. That gives us x equals y squared over 4. And our area, which ought to be the base, times 3 times the base, because those are just rectangles, right? 3b squared should just be 3 times y squared over 4 dy. And then we will integrate that from the lowest y value, which was 0, to the highest y value, which was 6. And I don't think it asked to evaluate, did it?
No, it didn't.
No.
Yep. So 2 points for having the right thing inside of here, and 1 point for having it all set up correctly with the right limits on the integral and having it in the integral and having your dy. Any
You have to
questions?
s-
Would
Do you
it
have
be
to,
right?
s-
Oh, sorry, I didn't square that.
Yeah.
okay, yeah.
Sorry about that. I wrote the squared up there, but somehow it didn't translate into my file. Now it's there. Now, are there any questions on that?
Could you write it as y over 2 to the 4th power?
Yeah, that's fine. If you wanted to.
Like they wouldn't take points off or anything.
No.
Okay.
I mean, there's no reason to, but it's fine if you want to. You write it as y to the 4th over 3y to the 4th over 16. That's fine too. Or yeah, as long as it's equivalent, it doesn't matter. All right. Any other quick questions before we start the quiz?
Can you just go over one more time, like when it's more efficient to use the shells versus the other methods? Just like, I remember you said something about like when we should use shells and when we should not use shells. Can you just repeat that?
Well, so like I said before, you won't have to use shells for anything on the quiz. But if you want to use shells, I would recommend doing it if trying to do it with a disk or a washer requires you, one, to maybe split it up into multiple different integrals, or two, if it's really difficult to rearrange the equation into the appropriate variable. So if you need to do it in terms of x for disks or washers, but everything's given to you in y and the equations are kind of complicated to like flip around, then try and do it using shells. Or if you got to split it into 2 or 3 different integrals to use disks or washers because the upper and the lower bounds of the region change, maybe look and see if the right and left bounds don't change, and then you could use shells and do it that way. Doing it in terms of y. Does that make sense?
Yeah.
Okay. Any other questions?